Hadoop on, leveraging big data with Informatica. Super quick, as everyone's time is valuable and we want to get to the content, I want to share a little bit about Datasource Consulting, which explains how we are knowledgeable in this area. We are a business intelligence and data integration consulting firm. It's all we do all day, every day. And because most BI and data warehouse programs fail due to the modeling and architecture, a staggering 65% fail, our specialty has naturally evolved to this area. These same considerations certainly relate to big data. As a services company, we offer assessments, especially for existing BI and data programs where there are questions on scalability or performance issues where users may be encountering latency or questioning the accuracy of the data. We also offer data architecture design and builds from scratch, data integration, complex ETL, data virtualization, data modeling, data governance, data quality, and vendor tool evaluation, all critical components of a successful BI or big data initiative. Some housekeeping, we have everyone muted, so I encourage you to utilize the chat for questions at any time during the presentation. At the end, we will save time for more formal Q&A. The presentation is about 45 minutes in length, and I strongly encourage you to ask questions. Personally, I have attended and presented on numerous webinars, as I'm sure many of you have as well. And from my experience, the dynamic and real-time conversation really comes from everyone getting involved. So please ask questions. We will also have contact information on the last slide, so you can always contact us this way if that is your preference. Let's go ahead and dig in. I'd like to introduce you to Tom Natz, Director of Data Integration for Datasource Consulting. Tom?
Thanks for the introduction, Deborah. Let me get the slide going here. I'm Tom Natz with Datasource Consulting. I head up the data integration practice here at Datasource. And since we're an Informatica partner, I get to play with all the Informatica software in our lab. I've been using Informatica for about a little over 10 years now, and I enjoy learning some of their newer products that are coming out. I was invited down to Informatica headquarters earlier this year for a week-long boot camp on the new Big Data Edition. We installed, configured, and performed many scenarios on loading a Hadoop cluster and writing mappings that use Hadoop as a source. In this webinar, we're going to provide a brief overview of Hadoop, some of the key architecture pieces that the Big Data Edition uses, and how this new edition works with this new technology. The next two demos I'm going to give in the webinar I'm going to be showing you today can be found on our YouTube channel, which is, the handle is DatasourceTV. And we have some other videos up there for different kind of Informatica products. So let's get started. So you might have seen this graphic before. Much like in marketing, where you define product, promotion, place, and price, in defining big data, the terms variety, velocity, and volume are used frequently. This is a great slide because as some of you have worked in this area for many years understand when I say life used to be so much simpler. We used to have night batch loads to deal with, tables that were hundreds of megs, and usually just a few databases. Within the last 15 years, things have exploded when it comes to the amount of data within a company. So let's go over each of these terms. Let's start with data velocity first. Before, we used to have just a handful of reports that were due early in the morning. We'd get up at 2 o'clock when the loads failed, get them back going again, and everybody was happy. Now it seems everybody wants the reports all during the day and at night, some of them in real time. Does it help for real time? For some, yes. Others, that's probably best used for probably another webinar. The next one we'll talk about is data variety. We've gone from simple table data in a source database to all sorts of different types, such as vendor data, social media, video, photos, XML, PDFs, and all that good stuff. And lastly, the most important is data volume. We've gone from megabytes to terabytes. A typical company, for example, now has social media, cloud vendor data, marketing campaigns, and external data. So what are some of the goals of big data? 3 years ago, say that again. 3 years ago, we had a client that was migrating from Oracle to Teradata. Reports took about 45 minutes on an Oracle rack system, and then after we implemented Teradata, they took 30 seconds. I was floored. I thought, how can this be? We can go back through 5 years of transactions, start to figure out what people are buying, their trends, etc. For some companies, big data has always been there. They just couldn't realize all the benefits and value of their existing data. So let's go over some of these goals. gather even more information. Before, the data you could collect was usually just limited to your source systems. Now companies are realizing the value of joining external data such as weather to gain additional insight for their customers' buying habits. Want to join your sales with the last 10 years of weather patterns? Now you can. Deep analysis is another big one. Now you can dive into your data like never before. An example is when people buy tennis rackets, they buy X amount of tennis balls that year. What other accessories do they buy when they buy a tennis racket? Another thing we've seen is loyalty programs have popped up everywhere. And the data is just great. It tells you what people are buying when they're buying it, but you need to analyze the data to reap all the benefits from it. And lastly is enable greater access. We were at a retail client and they were trying to figure out why certain SKUs and products sell in certain areas on certain days. Was there a sporting event? Was there a social media trend? Like a flash mob on jump ropes, something like that. So along comes Hadoop. It was originally created at Yahoo based on a Google white paper. We've seen people talk about replacing appliances such as Teradata and Netezza with Hadoop, but most of the vendors out there, like Cloudera and MapR, will tell you otherwise. Due to the high cost of these appliances, companies don't usually store all their data on them. With Hadoop, you have the ability to create a company-wide data store instead of holding recent data or pulling data off tape for analysis. Don't get me wrong, Oracle and Teradata and these other databases out there still have their places in the organization. On this slide, we're starting to get away from the single storage idea to a shared nothing architecture, with each node becoming a data processing unit. So this is the traditional part over here, and then on the right-hand side, that's where we're looking at for Hadoop, where the data lives on each of these nodes instead of being more of a shared architecture. So like any technology, everything changes every 5 years. We've gone from mainframes to personal desktops to thin clients to web browsers to virtualization, then back to Hadoop, now in memory databases. It's hard to keep up. The main thing to understand here is Hadoop has a specific use case that is holding and allowing analysis on a very large amount of data using commodity hardware. And I think that's the main point I like to make here is it's a specific use case. It's not made to take all your databases and now it just sits in Hadoop and everybody's happy. We've seen some vendors out there trying to sell it that way, but some of the better vendors like Cloudera and MapR will be the first one to tell you that it has its specific use cases. So some of the Hadoop features here is scalability. It's infinitely scalable. The idea here is you add more nodes, the faster it becomes. You're always limited by something called a name node, which we'll go over, which stores all the file locations in memory. Next is powerful MapReduce. There's a term out there called data to function that we're all used to that we may not know. When we write a query right now in a regular Oracle database or SQL Server, it's basically taking that data off disk, bringing it into memory, and doing your analysis on it. The idea with MapReduce is almost the other way around. It's function to data. So we're taking a function and analysis and we're bringing it actually to the data because it's such a large amount of data. The analysis programs are sent there. Let me go back. And number 2 is lower cost per terabyte. Using commodity hardware and really starting to get into compressing the data while it's in Hadoop. And then lastly is prevent data loss. This is obviously a big part here. Is you can store all this terabytes and terabytes of data, but if you were to lose some of it, that'd be catastrophe. So by default, the idea here is every single file is broken down into blocks. Each of these blocks is stored at least 3 times. That's the best practice is 3. So some of the core technologies that Informatica uses. There's a bunch of different technologies in Hadoop. There's probably 15 or 20 now, but the main 3 here we're going to go over that relate to Informatica. First is HDFS. It's the core file system of Hadoop. Basically, it's just a file system that sits on top of a Linux file system, and it's replicated under the covers, so your data is always safe. Next is MapReduce. We talked about that on the previous slide. It distributes processing across the cluster. And lastly is Hive. It was created at Facebook. They had a lot of these analysts out there that they didn't want to retrain and try to teach them Java and Pig and some of these other tools out there for Hadoop. They wanted them to keep with all their SQL skills. So they built a layer that sits on top of HDFS. And as you write SQL, it turns it into MapReduce and runs it, submits it to the cluster. So this is a slide that kind of goes over what the main components of HDFS. First you have data nodes, and that's represented down here. And each of these are data nodes, and each of the little mini boxes in here are blocks. And up here you have something called a name node. And I like to refer this as a librarian. For some of us that are old enough that had a librarian that knew every single book in the library, is we used to be able to walk in when I was a kid and just ask for any book, and she would usually know exactly where that book was at any given time. If it was checked out, if you know what rack it's in. So if we look at the way HDFS uses a name node, is the name node knows where everything's at. So if I wanted to place a file into the cluster, I would, let's say for this example, I'm pulling from Oracle, I'm using Informatica, and I have a file called cust, the date timestamp, .csv. I first ask the librarian, hey, where do you want me to place this file? So the librarian says, okay, I want you to break that file down into blocks. Block 1, I want you to send it to node number 2. And then from there, node number 2 is going to send that to node number 9. And then node number 9 sends it to node number 10. So as you can see here, we have our data separated. It's copied 3 different places here. And the idea is Hadoop has something called rack awareness. So when you set up all your nodes, you tell it what rack these nodes are in. So it knows to split this data up at least between one block goes to one rack, and the other 2 blocks will most likely go to another rack. So that way, if somebody walks up, pulls a power on an entire rack, your data is still safe out there. It's still you're still up. You're still be able to do MapReduce code for it. So when that's done, block number 2 comes along and says, hey, you go back to the library in the name node, ask her where it goes. This one goes to node number 11. It goes from node number 11 to node number 4, node number 3. Notice what's kind of important here is the block goes from node number 2 on block number 1. It goes directly from node number 2 to node number 9. So it doesn't come here, and you can imagine if you're starting to do a lot of things here, your name node would be the bottleneck here. No, all it is just a lookup. So now the name node has this block. It has what nodes these live in, but the actual data, let's say these are pretty big files that are coming in. They're going from node to node. And down here, as you can see, something called replication factor. By default, it's 3. You can put this as 1 if you want to, but the best practice is 3. So 3 copies of your data is kept within the cluster. So now we're going to quickly go over Hive here. Like I said before, it was created at Facebook, and it has a SQL layer on top of HDFS. You write queries that translate them into MapReduce and process it on the cluster. Hive is based on something called schema on read, which means it's the opposite of what we're all used to, which means you define a table structure, and only when you run a query does it go out and try to retrieve that data from the cluster. We're all used to creating a table, getting the space for it, and that's kind of flipped upside down. The benefit to this is speed to ingestion of data. If you have a new data source, you create a directory and you start transferring files into it. You can define it later if you want to. In this slide here, the way Hive works is it's basically going to create everything's based upon directories. So in here, I'm going to create a table called customer. It's going to go out to a metastore. I have MySQL here, but most of the vendors are supporting large databases like Oracle and SQL Server. So it's going to go out here and insert, just like in an Oracle Data Dictionary, insert a row in here and says, okay, I have a new table called customer. Here's the definition of it. And it's going to go create a directory out here called warehouse, just out on HDFS. So this is how a Hive query works. Here's a typical query that I'm going to do. I'm going to select from the customer table and I'll do a group by. It's going to come out here and use something called a Hive driver, and it's going to pull the Hive metastore information, use the Hive driver, writes MapReduce, goes out there, retrieves the data, and returns it back to, well, getting my mouse messed up here, and returns the results back to the end user. So how do I load a Hive table? Do you think there's some kind of special loader? There's not. It's basically you define the structure of the table, which is a directory called customer, and now you're going to lay or insert files or transfer files into the cluster under this customer directory. So I'm going to do a quick little demo here. We're going to load from an Oracle customer table into HDFS, and I'm going to use the developer tool. I have a little video here, kind of go over it. Hopefully everybody can see this. This is the developer tool in Informatica. On the left-hand side here, we have a customer table from Oracle, and I have an expression where I'm adding 2 metadata columns, and my target is going to be HDFS into the customer. So I come down in here, I'm going to click on the target here just to show you that, I don't know if you can see it or not, but the connection type is Hadoop, and my directory has customer here, and then my file name is going to be called customer_2.csv. This is just for my example. So don't know if you'll be able to see this or not, but it looked better when I was doing it before. I'm going to highlight the directories here so you can actually see it. But I'm actually going out to the Linux server here, and I'm looking into the Hadoop directory. Well, I guess you can't see it. So there was basically, when I did ls in there was nothing in that customer directory at all. Now I'm going to pull from Oracle, run this mapping. It's going to insert into Hadoop. And I'm going to use the Informatica Monitor, the web-based monitoring tool, to monitor the job. I think it pulls about 700,000 rows. So it takes about 20 seconds here to run. So that's completed. And I'm going to go into something called Oracle Toad for Cloud. It's a free product from Quest that connects to a variety of different kind of a newer databases such as Cassandra, Hadoop through Hive, and probably 5 or 6 different ones out there. Mongo is another one it connects to. So it just gives me that familiar SQL-like interface here where I'm going to select star from customer. It's going to limit it to 100, and that is my information. So that's basically going out there, writing MapReduce, and pulling anything in that directory. Well, I only have one file that's out there right now. So I'm thinking I'm going to go back to my putty session here, which you probably can't see. I believe I highlighted here. And I show there's a file out here called customer2. So that could be done with, it could be done with Power Center, it could be done with a regular FTP. What we're doing here, and when we use that Hadoop file connection, it's actually doing something called a copy from local. So it's taking this information, pulling it from Oracle, creating a temporary file on Hadoop, and then using something called copy from local. So it's copying it into the cluster. So let's talk about how Informatica is dealing with all the different kind of big data technologies out there. So as you can see from this slide, we have a lot of different products out here. We have Power Center for Enterprise Grid. We have PWX, which is Power Exchange for Hadoop, Power Exchange for social media. We're going to concentrate on something over here, just Power Center on Hadoop. They've had something called HParser out for, it's been a couple years already. So we have this concept of something called Hive Pushdown. Just like everything else in Informatica, the idea is you don't have to go learn coding. So along comes Hadoop. You have to learn something, either Java to write MapReduce, you have to learn Pig or Scoop to get data in and out of Hadoop. And the idea is the reason why you bought Informatica, because they shelter you from this. The idea is you keep writing mappings. It doesn't matter what your source or target is. So on something called Hive Pushdown, the idea is when you're pulling from your cluster, you should be able to write any kind of mapping you want. And from here, it's going to take that, use something called a Hive driver. That's using Hive, something called HQL, which is HiveQL. It's going to write MapReduce. And what it can't write MapReduce in, it's going to use something called a UDF. It's going to create a user-defined function or many user-defined functions. In this slide here, this transform function right here, it's something that it can't do using Hive QL, so it's going to create something called a UDF. It's going to take this and submit it to the cluster and return the rows back to your mapping. So I'm going to do a demo here of something very simple. If I can get it on the right screen here. Okay, let's start this over here. Okay, in this demo I have 2 Hive tables, one called customer, the other one called customer order. I'm going to join them together. It's going to go through an expression, and then I'm going to do a lookup into Oracle, and then I'm going to do some aggregate the data, and then I'm going to insert the aggregated data into an Oracle table. One thing in the developer tool is nice is that you can do data previews. So in here, in this Hive table, I'm going to do a data preview to see what's in this table. But what it's doing, it's writing MapReduce in the background. So everything is batch oriented in Hadoop, so that takes a little bit. So I'm using the distribution from Cloudera. So they have some tools that they provide with Cloudera. One is called Beeswax, and this tool here is called Hue, where you can actually just write queries directly against Hive. And so I'm going to do basically the same thing I did in that Toad, that Cloud for Toad. I'm going to select star from that table. And so that just came back. So that took, probably about 30 seconds, 45 seconds to look into that table. And so now what I'm going to do is I'm going to run the mapping. And again, we all have to remember that this is it's a batch-oriented system. It's not made to bring back rows in 5 or 6 seconds. It's made to go over terabytes and terabytes of data. So my little 700,000 rows here I'm doing is going to take just as long as I'm going through a couple 100 million. In the monitor tool in 9.1 and actually this is 9.5 that I'm running here, you can actually see the execution plan. So what it's doing here is it's going to take both of those Hive tables. It's going to take that lookup that I did against Oracle. It's going to create a temporary table in Hive. So it's going to pull that data down from Oracle that I need for my lookup, and it's going to create this lookup table. And then what it's going to do, it's going to join all 3 of those tables together, and it's going to create another temporary table in Hive in order to do that aggregation. So I'm kind of going through here in the demo, just kind of click on each one of these here. You can see where there's some create table statements here. Here's an insert override, customer region lookup. So it's actually inserting, it's doing an insert as and then select. And then it's completed here. So it took, about 2 minutes and 40 seconds to run that. Something that usually would run just a couple seconds. And so now I'm going into Razor here. I'm looking into that table, and here's my aggregated data in Oracle. So as you can see, I didn't have to write any code at all. No Java, no Pig, no Scoop, any of that stuff. So where have we seen this implemented in the last couple of years? A lot of you have seen this diagram. It's pretty simple. You have your sources, your staging. A lot of people implement things differently here, a data warehouse or an ODS or third normal form, whatever you want to call it, and you have a presentation layer. This is where we've seen Hadoop in a lot of larger companies is taking over this staging area. Before, some people have persistent staging, which is great because you can have history. It's great for reloading, but it costs money to keep all this in here. And so that's what Hadoop is great for. It's just dumping all your source data into here as you can. And then from there, it's going to feed other systems. Either it can feed your data warehouse, different kind of sandboxes you have out there. You notice this line right here is important. Having users, some users, not all obviously, some users have direct access to Hadoop. So the idea is your data warehouse, you're not having all the way line item data here. You're having somewhat aggregated data in your data warehouse, and then from there, you're going on to your data marts. And when I say line item, I'm not talking about sales line item. This could be 10, 20 years of data, all sorts of different kind of data that a lot of companies have never thought about storing before because it costs so much money. So why use Hadoop for staging? Well, the ability to load data as is without predefining a schema, which increases flexibility and speed of delivery. That's a good one. I remember hearing listened to a guy talk. I think it was the ex-CIO of Yahoo, and he was all proud of it took 2 months at Yahoo to get a new table built by the DBAs and all the stuff they had to go through. So now it didn't matter. Now you could just create it and go on the fly. And that was real scary to me when I hear people talk about just creating stuff and just going. There still needs to be structure. The fact is you can create it. You saw me create a directory, create a Hive table, it creates a directory. You can start loading data into it. You don't even have to create that directory in Hive. Using Hive, you could just go out there, HCFS, create a directory, and start dumping data into it. That's what's so flexible about it, but there's a reason why there's processes and governance out there. Another one is can store, cleanse, and aggregate persistent history at lower cost performance than traditional database management systems. And that's the one thing we're talking about with that big Hadoop data store. Another thing is option in here is the ability to leverage the operational data store for low latency reporting. again, replacing that ODS that a lot of companies are doing, you're able to do that a lot cheaper now. And can feed analytics sandboxes for exploratory, and that's what we're talking about, giving some users direct access to the cluster and providing better analysis capabilities for unstructured data. So some of the gotchas on this. Hadoop's great for fact data, not so much for dimensional, and we'll go over these three in detail here. It's designed for larger files. It's not made for very, very small, files that have 5 or 6 rows in them, and it's batch oriented again. So what are we talking about for persistent staging? There is no updates. A lot of us are used to being able to, in stage, having a persistent staging where you're keeping multiple rows of a customer as they go through. So here I have an example here of Fred Jackson. The insert date was February 4th, and Fred has changed his phone number. So if you can look here, we have an employees directory, and we're dumping files into this directory. Well, they're very small files. And that's the problem with Hadoop. It doesn't do very well with files because your name node has to have a lot of memory to keep a lot of this information out there. So HDFS was designed for many millions of files, many millions of large files, not millions of small files. I found this little note up here from a Yahoo white paper here. This is based upon Yahoo's average use of files. For them to store 100 million files, their name node needs to have at least 60 gig of RAM. Now keep in mind that if that name node goes down, your entire cluster goes down. That's the main part of Hadoop. And they're working on ways to do a true secondary name node and peer-to-peer, high availability, and that kind of stuff. Some of the vendors are working on that. The way to get around some of this is consolidate your deltas. There's a company up in Seattle that does this. Every month they have a lot of different kind of files coming through with changes from dimension tables. What they do is they consolidate those. They pull them out and they create one big file for them. Another option is to use something called a HAR, which is kind of like a tar in Linux, where you actually have one file out there, but it actually equals 20 or 30 or 50 files underneath it. And lastly, it's batch processing. I have a line up here directly from Hadoop. It's based upon batch processing, and a lot of people forget that. People think it's just so much faster than a lot of things. Well, when you're dealing with hundreds of terabytes that you want to go through, then yes, it is going to be faster than a lot of different databases out there. But if you want just quick results from sales from yesterday and that kind of stuff, it's not there to replace that. Things are changing. Some of these Hadoop vendors are getting into more real-time queries, like Cloudera has Impala, and a couple of the other vendors are out there that are coming out with their very similar technologies. So that's about it to cover that. We have some useful links on our website at Datasource Consulting, and then of course our YouTube channel here with the different videos I went over today. So here's our contact information. You can just contact me directly, and I have some more videos, and I have some more white papers and a lot of different kind of research I've done on this. And we've sat with 2 or 3 companies that are using Hadoop, and it's been interesting to see where they're going with this technology. So if anybody has any questions, they can just submit them in the chat window.